Hi everyone, welcome to this NPTEL course on combinatorics. So this will be the first problem solving session for this course. So whenever there is some audio issue or some interruption or you have some doubt, you can directly unmute yourself and ask me about that. Okay, so let's start. So uh, so this first week is mostly about pigeonhole principle and its application. So let's recall the theory quickly and then do the examples and exercises and all that problem so that we have some idea at least because the main like in other courses basically what we do algebra courses there the main if you are able to develop some theorem then you can see its application clearly, but here the problem is that this simple principle like kind of pigeonhole principle which seems more or less obvious, but applying it to practical problems seems requires a lot of reasoning. So we will see today problem solving these things in problem solving session. So let's start. Let me quickly recall what this pigeonhole principle is. So okay, pigeonhole principle. Okay, so what is this? Suppose we have k plus 1 balls and we need to place that k plus 1 balls in k boxes and k boxes. Then at least one box must have two or more balls in it. Okay, this seems intuitively clear, right? We have k boxes and k plus 1 balls, so one of the boxes is going to contain more than one ball. That is fine. So just quickly recall this strong pigeonhole principle also, and we will see the application. Strong, I hope the spelling is correct. Strong pigeonhole principle. This says that uh, let n1 plus n2 plus, where n1, n2, nk are positive integers, minus k plus 1 balls are put to k boxes, then either the first box has n1 balls, or second box has n2 balls, n2 balls, or kth box has nk balls. So this is the theorem we will use for today's problem solving session. This is also done in your this week lectures in course. So I'm just quickly recalling these things. So first thing is pigeonhole principle, which says that if you have k balls and k plus 1 balls and k boxes, so one box will contain at least two balls or at least two balls. It can contain more than two balls, and strong pigeonhole principle is just its generalization, but we will see its application in today's class. Okay, so apart from that, we also did this Ramsay theorem and Dirichlet theorem, then this hypergraph things, and then by using that this infinite version of this pigeonhole principle, like if we have finite boxes and infinitely many pigeons, then one of the box should contain infinitely many pigeons. By using that, we also proved some result of analysis kind of this bounded value as what called Bolzano-Weierstrass property by using this infinite version of this pigeonhole principle. So all of this has been done in class. So let me quickly go to start with problems now. Okay. So if I will need Ramsay theorem, then I will write it at that point. But let's leave for time being that. Okay. So let's start with problem. So let me open the problems. Okay. Start with your week zero assignments. Let's say. So I hope you already know, but for starting of session, since this is 2 hour session, so we have enough time. So question. Please discuss the solution with me. These are easy problem. Cardinality of x is n. X is a set. Just give me idea how you will do this. Then how many subset X have? You can unmute yourself and answer this. Let's
2 to the
start
power n.
discussion. So how we will do that? Your answer is, can you give some idea?
There's a choice of picking one element and then not picking the another. So you repeat that choice n times.
Correct, correct, exactly. So this is one idea. Anyone have some other idea? Each
So
element have a choice. Either you pick it or not pick it. So this is going to repeat 10 times. So we have 2 to the power n choice. This someone gave this argument. So anyone else?
so we can formulate GP also, like we have no choice, two choice. I mean, if we formulate GP,
I didn't get. You mean GP means geometric progression?
yes. So if we have
So
10 number, so there could be say no elements or
okay.
one or no, that won't work. I was thinking
But
that
how?
probably we can use binomial theorem kind of something.
But I don't see clearly that proof. Can you? Okay. I don't know. Maybe there is some proof by that, but I don't know. At this point, I cannot understand your idea correctly. So if someone understanding can point out. So another way of doing is that which basically I prefer to do is by induction. Basically, base case is clear and then do for n, then for n plus one is obvious. So do I need to write it or you understand it clearly, right? So I don't need it to write.
Can we use
Everyone is clear with this?
combinatorics in this, or like combination NC1
Yes.
plus NC2 plus NC3, and we add
Okay.
them and
I got your idea. Right, right. You are correct. Correct. Okay. So this is the basic thing. I am not going to write a proof. I hope you all are clear. If you need, you can ask me. I can write that proof also. So this is your assignment zero. A drawer contains three red, four blue, five green socks. If socks are taken at random in the dark, what is the minimum number that you will have a pair of same color? What is the minimum number so that you will have pair of same color? Tell me, anyone? Anyone?
4.
Okay. Justification?
You are picking, if you pick two of the from red, you are done. If you pick two of from blue, you are done. If you same for green, then the third, if you
Yes.
in the then the third one has to, if you pick separately of each one of each color, then the third one has to repeat. So you are done with
Yes,
a
you
pair.
you are correct. So basically, precisely, you are using a strong pigeonhole principle, N1, 2, N2, 2, and N3, 2, and you have three boxes. So this says that N1 plus N2 minus N plus N3 minus K plus 1. This is 6. Sorry, this is 2. Minus 3 plus 1. This is 4. So you need to make four choices. Yeah, this is fine. What else? A simple four regular graph on n vertices will have edges. Question. A simple four regular graph on four vertices, on n vertices, sorry, n vertices will have how many edges? Let me not give you option. You should answer it without giving option, right? So tell me. So we have a simple four regular graph on n vertices. So what will be, how many edges it will be? By regular graph, we mean that each point the degree remains same, right? The like total number of edges going from that point is same basically. Some people, I guess it is defined as a degree. So each point have same degree. So
We will
can you argue
six edges.
how six edges? Because I didn't put any restriction on vertices. For how many vertices you are saying six edges?
Like in four
For
regular graph, we will have six edges.
for any vertex n number of vertices. Let's see with let's see with two vertices, right? So four regular graph means for each point we have going four edges from this point, right? This point has should have degree four. Ah, so there should be four edges between them, right? So can you see now? We have n equals to 2 and we are getting four edges.
Will it
So
be
if
clear?
we have
We'll have
hmm,
two n edges, I think.
Well, sum of the degree
so
of
how
vertices is equal to the twice of the number of edges.
your audio is not. Can you say again?
So sum of the degrees of the vertices is equal to the twice of the number of the edges. So the sum of the degrees of the
Sum
vertices,
of degree of vertices
yeah,
is equals to
twice of the
what you are
number,
saying?
twice of the
Twice of
number of
number of edges, right? Okay. So how you will prove this? I'm asking for a proof of this.
we can take the help of the handshaking lemma kind of the thing because
What help? What help?
so we can use handshaking lemma kind of the thing wherein
What?
everything is getting counted twice. So
Okay.
yeah. So since every vertex, in order to in order to form an edge,
But
one
if I need to do this, I will do this by induction. I have clear cut, like I can see it for base case. I will assume for n, then I will generalize it for n plus 1. So this seems immediate to me, but your idea is also what you are saying is also making some sense to me. But yeah, we can do by anyway. But at least induction, by induction, it is clear to,
yes,
or I need to write a proof for that. By induction, it should be clear, right?
yes, yes.
Everyone, if anyone, if to anyone it is not clear, I can write a proof, but please respond if not clear. I hope it is clear. So that means we have two n is justification. I can just write use induction. I can just write. Okay, this is last question of assignment, your zeroth assignment. Okay, there are two more questions, but these are very simple. I don't think. Okay, so this is last. Then we will go some good problems. So What is the number of subsets of? So I'm writing with red pen, I guess. So let's write with red also. What is the number of subsets of 1, 2, 3, 4, 5 containing 1? Answer this is very simple. Just answer it. Unmute yourself and answer. Anyone? This is simple. Just unmute and answer.
So, 1, 2, 3, 4, there will be 16 subsets.
How? Justification?
Because for the remaining 4 elements, we can have 2 raised to the power 4, the 16 number of the subsets, and
Then
then we
we can
make
just union now all with 1, right?
yes.
Every subset we can union with 1. So we will have this 16 subsets, right? So this is correct. So this is 2 to the power 4. This is equals to 16. Justification is take all subsets on remaining 4 elements. That will be 2 to the power 4. And just take union of each subset with 1. So this is the okay. So there is another question like that is simple, I guess. So you can just okay. Let's write that as well. This is another question in your week 0 assignment. So question. This is saying you have a fair coin that you throw twice. You have a fair coin that you throw twice. What is the probability you get head exactly once? Let's say what is the probability you get head at least twice. Fair coin that you throw ठीक है twice. Head at least once. Okay, at least once. Twice only. Answer it just quickly.
3/4.
3/4, right? So because your sample space is either it can be head, it can be head tail, it can be tail head, it can be tail tail. So so that means so we have three. So where we are getting head at least once. So this time, and this time. So this one, and this one. So we have 3 out of 4. 3 by 4. So yeah. So this is done with this week 0 assignment. So let's go to good problems. So I will solve some problems. So let's start with this one. Right? This seems me interesting. Let's start with this question. Okay. So let let m equals set of n positive integers, none of which has prime divisor larger than 4. Then M has two distinct elements whose product is perfect square. Okay. So for the question is what is the least choice of n for which this statement is true? For which this statement is true. Okay. Question is clear to everyone? So this is saying that m is set of n positive integer, none of which has a prime divisor larger than 4. So possibilities for prime divisor is either it can be 2 or it can be 3, right? So then M has two distinct elements whose product is a perfect square. So this M should have two distinct elements whose product is a perfect square. So what is the least cardinality of such a set? I am asking this question. So anyone, any idea how to proceed?
The elements are of type 2k and 3k, right?
Yes, yeah. 2 alpha, yes, you are correct. 2k1, 3k2. Right. This type of elements are in. So I am asking about cardinality of M such that this statement holds. K1 and K2 are positive integers. हाँ, कलर चेंज हो गया. Tell me, any idea? How to approach? Suppose we have one element x1 is, let's say, 2 to the power a1, 3 to the power b1, and another element x2 which is 2 to the power a2, 3 to the power b2, right? I
I
want
think
that
3.
you think 3.
Yes,
Okay.
because
So,
the power, if both of the powers are odd, then
okay.
if I get another power in, so their addition would end up being even. So we have a perfect square.
Okay. Let me give you a three element set such that nothing is a perfect square there, and none of two elements product is a perfect square there. So let me give you the set. Which has prime divisor. This is none of which has a prime divisor. Or if you take this one, will this work? 1, 2, 3.
No, no, I got it wrong.
Yeah. Where you are wrong, have you got that idea? Why you are wrong? But your idea is correct. You are not, but your answer is incorrect. Basically, your idea is correct. Idea should be in that way only, but your answer is incorrect. Yeah. So anyone else can unmute yourself and
It is
answer.
not
I
necessary
have
that.
given you enough hint that. Yeah. Tell me.
Ah, okay. So the value either of K1 or K2 could be a zero also, because it is not necessary that a number has to be divisible by 2 and 3 both. So
Yeah, it is not necessary. A1 can be zero, right? That's why I write natural number union zero.
yes, now I understand. Okay.
Yeah. So what? Anything else? No idea? Okay. I should give some more hint, then you will proceed. So let's take x1 dot x2. So what it will be? It will be 2 to the power a1 plus a2 dot 3 to the power b1 plus b2, right? So, what happened? Yes. So, I want to make this perfect square. So, for perfect square, what I need basically, I need this should be of this form, right? So that I can write 3 to the power b1 plus b2 by 2 a whole square. So that I can write in this form. This is intuition. Don't take it precisely. This is to give you intuition. So, huh. So we need this thing, right? So that this a1 plus a2, we need even. Okay, yeah, we need a1 plus a2 even. So what is the choices for a1 plus, when the a1 plus a2 will be even? What is the possible choices for a1 and a2? Can you tell me? Now you should tell me, right? Now this is more or less clear. No one? Okay. A1, okay. A1 even and B1 B even. A1 odd B1. Okay. Okay. So what we need basically? What is the possibilities? So A1 even A1 even A2 B even A1 odd तो A2 भी odd अगर होगा तो odd plus odd even हो जाएगा, right? Then B1 odd B2, then we need also B2 to be odd. If B1 even, then we need B2 to be even. Okay. So once we are going to pick 5 elements, then we are going to get this thing, right? Because once we are going to pick 5 elements, we have this 4 boxes: odd, odd, even, even, odd, even, odd. Like we have these 4 boxes. Once we are going to pick 2 elements, then they are going to give this thing us, right? Are you getting my idea or not?
Yeah.
You are getting? I should be more clear, but let me write it again. Let me write it again. Let me write more clearly. Okay. So what is the A1 A2? What is A1 comma B1? What is the possibility for A1 comma B1? It can be odd, odd form. It can be odd, even. It can be even, odd. It can even. This is the only possibility, right? But once I pick 5 elements, then the fifth element will be one of them, one of this. Once I'm going to multiply this, then odd plus odd will be even. Like suppose I am choosing 5 elements, the four like then one of 2 elements should by pigeonhole principle. So let me write. Once I choose 5 elements, then by pigeonhole principle, 2 elements, let's say them box 1. This is my box 1. This is my box 2. This is my box 3. This is my box 4. Then 2 elements will lie in, at least 2 elements will lie in same class. Then this is, let's say x1 and x2. Let's say them x1 and x2. So this implies x1 dot x2 will be perfect square. Okay. Now ask me if it is not clear. If clear, then it is fine. Is this clear or not? Tell
Can
me.
you show the question, please?
Yes, this is the question.
Uh, Okay. Yes.
Is this clear or not? Anyone, any doubt you can ask at this point. Because we have 4 choices. Once we are
I
going
just
to choose
want,
fifth element. Yeah,
I
yeah.
just
Ask,
wanted
ask.
to ask, how are we sure that the four, like we are choosing five elements, so how we are sure that the first four are giving us distinct classes?
Okay,
Are we?
if they will lie in some same, if they lie in same class, then we are already done, right? If they suppose we are given 4 elements and 2 element lies is odd class, then we are already done because their A1 is odd, B1 is odd, and for first element x1, A1 2 to the power A1 and 2 to the power B1, A1 3 to the power B1, A1 is also odd, B1 is also odd, and for x2 also 2 to the power A2 B2. This is also odd for 2 elements. If they are odd, then we are already done. If odd plus odd is going to be even, so they are going to be a perfect square, right?
Yes.
So we are done in that case. Is this clear?
Sir, when we say we are choosing 5 elements,
Hmm.
sir, then you are saying that we'll fall into one of these buckets.
Right.
Sir, but is it necessary for the count to be 5, or anything less can also give the same result?
No. 5 is least. Like for lesser than 5, it can happen, but it is not necessary. There can be counter example. Like for 3 case, I already give someone. Someone said 3, then I gave him some example.
Okay, 5 is the least number after which we
Does
are
that?
sure that one of the bucket will be.
Yeah. One of the bucket, like the 2 distinct element will have a perfect square.
Okay.
So now the task for you is this. Okay, let me modify this question for you. This is your homework. Replace this prime by, replace this statement 4 by 6. Then do this question and you should get an answer 9 and justify yourself that you are getting this idea or not. So this is your homework. Now your M is the set of n positive integers, none of which has a prime divisor larger than 6. So now you have one more prime increase. So now your numbers will be like 2 to the power AI, 3 to the power BI, 5 to the power CI. So now you have to do for that, right? So just do that. And if you have any doubt, you can ask in next session. This is similar calculation for 6 also, right? And what modification we can do this? This is only 12, right? Another of doing, okay. Another question I can ask from this question is, what is the least choice of n for which these statement, like this statement I can also modify in this way, right? Perfect square के place पे perfect cube कर देते हैं. Perfect cube. Can you answer this then? Try all these things. This is good exercise for you. I have gave you enough idea in this question. So these two are exercises for you. Try to do that in your home and let me know if you have any doubt in next session. We can discuss it there.
Sir, will you be sharing this document after the session, or we have to make
Yeah,
our...
yes. I will share it. I guess you have got some drive link, right? There I will upload all these things.
Okay, sir.
Okay, fine. So this is the first question. Let's do another question. Okay. So this is interesting one. At least when I am doing this, I found it very interesting. So given question, given set x is equals to 1, 2, 4, 2n, right? And any subset S subset of X such that cardinality of S is n plus 1. Then what we need to show is that cardinality of, for any subset S subset of such that cardinality of S is n plus 1, there exists A comma B in S such that A divides B. Solution. So anyone, any idea? Any idea?
Uh, I this was the problem in the lectures, right? This was given in
Okay.
the lectures.
Okay, nice. So this is given in lecture. So how you will proceed?
So I will use some n representative sets for the sequence of first n natural numbers to say that each set contains the so example for if you have
Okay, what are
a
your sets? Okay.
so, if some number divides then said number has an associated set. So n sets for the first n natural numbers. Then each set will have 2n by whatever the number you are dividing, floor minus 1 elements.
Okay.
So will it be better if I share it in written form? I have it written down actually.
You can share a screen, right?
Okay, I will share it as a picture in the Zoom chat.
Okay, you can share. I can check. Zoom chat. Okay. Chat. Everyone can check your Zoom chat. So till now I can't see anything here in Zoom chat. Okay. So you are saying that we define n representative sets for the elements in the sequence of the first n natural numbers. Let A is less than n. The representative set of A contains the numbers. Okay. The numbers. From the first n natural numbers. Let A is less than n. Then the representative set of contains the numbers which it divides in the set 1 to 2n. Okay. Each set has at least one element. Okay, fine. That is that. Moreover, the set of A has 2n floor A minus 1 elements. That is fine. Assume for the contradiction that S has no A comma B such that A divides B. So constructing S from U equals to 1 to 2n, it is evident that if A is less than n, A belongs to A, then at least one element cannot be selected without violating A does not divide B for that A. This leads to having zero elements in. Okay, fine. Maybe you are correct. Yes, could be correct. I can read it later, but okay, fine. Anyone else? Any idea? I can give my idea what I am thinking, but you can give your idea. Your solution I will read later. You can just send me also this person because after okay, I can download it after Zoom meeting and we'll check later. Anyone else? Okay, no one. Then I should answer, right? If no one is else interested to answer this, but this seems interesting problem, right? Okay. So first of all, let's do the other part. Why this is not true for n case, and give example for cardinality s equals to n case such that above condition does not hold, right? Okay, let's do this. Let's uh, start with giving counter for n cardinality. So let's see. So let's say your x is of 4 cardinality, 1, 2, 3, 4, and your s is 2, 3. You are done, right? So this is your for second part, the counter example. For n case, it is not. And for n plus 1, let's do proof. So, okay. Consider these sets. Okay. Consider, okay, these classes up to 2n for between, okay, let's how to write this, between 1 to 2n, we have how many? An odd and an even integer, right? An odd integer. Consider classes corresponding to each odd integer. How I am considering these classes? By these classes, I means class of an odd integer of the form 2k plus 1, elements which lies are of the form 2 in the class of 2k plus 1. So let's write in this way, class of 2k plus 1, elements which lies are of the form 2k plus 1 dot 2 to the power r, for r belongs to natural number, r comma k belongs to natural number union 0. Right. So these classes I am going to consider. Okay, let's do for some example, then you will be more clear. So let's take n equals to 5. Then we have 10 cardinality set x. X is 1, 2 up to 10. Then we choose. Okay. So then what are these 2k plus 1 will be look like? These classes will be look like 2k plus 1. Let's choose first k equals to 0. Then this will be 2.0 plus 1. This is class of 1. But how it will be look like? It will be basically what? It will be what? There will be 1, there will be 2, there will be 4, 2 square, there will be 2 cube, that is 8. These are only, right? Now, class of, when you put k equals to 1, then class of 3, how this will be look like? So 3 dot 2 to the power 0, that means 3. 3 dot 2 to the power 1, that is 6. If you exceed then that will exceed this. Now the class of 2, sorry, class of 2 into 2 plus 1, that is class of 5, that is what? 5 and 5 into 2, 10. Now class of 7, 2 into 2 into 3 plus 1, that is class of 7, that is 7 only. And then class of 2 into 4 plus 1, that is 9. So that is 9 dot 2 to the power 0, that is 9 only. So now I represented every number in this form, but why this is significant, I will tell you. But can you first of all tell me why every number can be written in this form? Can you tell me? Anyone? Every number between 1 to 2n can be written in this form. Anyone can tell me? Please unmute yourself and you can tell me. Even not between 1 to 2 and any integer can be written, any positive integer can be, you can write in this form for k, r and k natural number union 0. Why? Unmute yourself and answer, please. This is some basic theorem. You should able to answer this.
Is it related to prime
Any-
decomposition?
Yes. We have unique prime decomposition, right? Because any other prime other than will come from this 2k plus 1, right? This because that is going to be odd. Except 2, every prime is going to be odd. So any other thing will be come from here or so this is a prime decomposition. I am writing it in another way. Nothing more than that. So we have this thing. Okay. Now we have clear cut thing. So for if you are choosing, since given what we are given cardinality of S is n plus 1. So if by pigeonhole principle, if S has cardinality n plus 1, then S will have at least what? At least 2 elements from same class, right? Is it clear or not? So by pigeonhole principle, S will have at least two elements from same class, 2k plus 1. Then 2k plus 1 class. So that means, let's say x1 and x2 are this. So how they will look like? X1 will be look like 2k plus 1 dot 2 to the power r, and x2 will look like 2k plus 2 dot, sorry, 2k plus 1 dot 2 to the power s. So now suppose r is less than s or s is less than r, anything, r is less than equals to s, then it is clear that x1 divides x2. If another thing hold, then x2 divides x1. If, okay, let's write in this way. If r is less than equal to s, then this implies x1 divided x2, or if s is less than equals to r, then this implies x2 divides x1. So we have this thing. So we got required choices of A and B. Is it clear or not? Any doubts? You can ask me.
Sir, can you please explain it again, sir? Didn't get it.
Yes, sure, sir. So between 1 to 2n, we have n odd integer. This is clear, right?
Yes, sir.
So we have n odd integer. So corresponding to each odd integer, I am constructing a class by 2k plus 1. By how? In this class, the element will be look like of the form 2k plus 1 dot 2 to the power r. So that means, okay. So this I explained by example. This is the example I gave for n equals to 5. So in the class of, let's say, n equals to 1, in the case of odd number 1, what the element will be look like? 1 dot 2 to the power r. So 1 dot 2 to the power r means 2 to the power elements of the form 2 to the power. So 1 is the 2 to the power 0, 2 is the 2 to the power 1, 4 is the 2 to the power 2, and 8 is the 2 to the power 3. If you choose 2 to the power 4, then it will go outside the set. So we are not interested in that. So we are considering this classes. We are breaking this set 1 to 2n into classes basically. So this is basically breaking this set into equivalence classes. Then the second one is we are considering the class corresponding to the odd number 3. So then it will be like 3 dot 2 to the power r. So so if we choose r equals to 0, then 3 dot 2 to the power 0, that is 3. If we choose r equals to 1, that is 3 dot 2 to the power 1, that is 6. If you choose r equals to 2, then it will exceed the set. Similarly, so this thing. So we have total 5 classes, right? If we
Yes.
choose yes, if you choose n equals to 5, then we have 5 classes. So if you choose 2n, then we have n classes similarly by same argument. We have n odd integer. Corresponding to n odd integer, we have n classes. So we are given a set of cardinality n plus 1. So by pigeonhole principle, if you have the cardinality of set n plus 1, then among these n plus 1 elements, one of the elements, two of the elements should lie in same class, same
But
odd
sir,
class,
we
right?
only have n odd elements, sir. How can you get
So
n plus 1?
that's what I am saying.
Yes,
We
sir.
have odd elements, but in odd classes, we have even elements, right? Because every element has a unique decomposition in this form.
Okay, sir.
This is this is basically the prime decomposition theorem, because any other prime will come from here, and 2 is I am writing there. Are you getting or not? If it is
Sir, a
not clear, I
little
mean,
bit confused.
why confused? What is the confusion? Explain.
So
What is your confusion?
we have created 2k plus 1 buckets for
Yes,
which we want to now put all the elements which belongs to those bucket according to the formula 2k plus 1 into 2 raised to r.
but you can see clearly that every element is going to sum of one bucket, right?
Yes, sir.
Because any element can be written in this form, right? By
Yes,
this
sir.
prime decomposition theorem.
Yes,
So
sir.
so we have n buckets and n plus 1 elements, right? This is the thing.
Yes, sir.
So
Okay, sir.
at least,
Got your point. Samjha, sir.
yes. So yeah, so now it is clear. So we have
Yes, sir.
one bucket at least containing 2 elements. So then the funda is clear. We have that these 2 elements are the required choices.
Okay, sir.
So anyone else? Any doubt? or it is clear? Anyone? Any doubt or clear? At least respond so that I can understand whether you are understanding or not. Any doubt?
Sir, can you take up the page once again?
Okay. Where?
Yes, yes. One second.
Okay. Sure.
Yes, yes. And
Is it clear now? Clear or not?
Sir, one thing, sir. Sir, when you say the bucket number 1, for which the
Okay.
values are 1, 2, and 4, 4 and 8,
Huh?
so we mean to say over here is they are of the form 2 into 0 plus 1.
They are of the form 2 into 0 plus 1 dot 2 to the power r.
Oh, yes, sir. Yes, sir. Sorry, sir. Yes, sir.
Yes. Yes.
Okay, sir.
Anything else? Any doubt?
no, sir.
Okay, let's go ahead. This is another interesting problem. But actually, when I was thinking, okay, let me tell you. Also, this is session is going to be recorded, so I should not say this intuitive way. But when I am doing this, starting this problem, because I am also new to this area, I work in algebraic geometry. So how I was thinking this problem is that I am trying to break this set. I start with n equals to 5, let's say. So how I approach this problem initially? Then I break this set in the like 2, 4, 6, 8, and 10. This is going to lie in this class. Then I try to break this 3, 6, 9. Then the class of 7. Then the class of 5, 10. Then the class of 7. Then I try to look in this way, like these are the primes, so they are going to give me a 4 cardinality set in which this does not going to hold. Then what we can do? This is the intuitive way of trying to approach this kind of problem. You can also try to do it in this way. So this may be helpful for you a lot of times. Close this in this way only. So you can also do this. Fine. Okay. Another problem. Given set of 52 integers, positive integer. Let's do for positive only. Because otherwise you can just take negative sign and do the same calculation. So question. Given. Why I choose red pen? I'm writing to black white. Question. Given set of 52 positive integers, given set of 52 positive integers, then there exists two elements whose sum is divisible by 100. Right. So how to approach this? Any idea? Any idea? This is also interesting. After this, we will do some more interesting question. Like we are increasing the level. First, we do some
Like
basic thing.
there would be 51 such combinations wherein the sum of the two numbers is 100. Like say 1 and 99.
How this combination? Like, can you tell me again?
So yeah, like say 1 and 99 and 2 and 98 and 3 and
1 and
97.
99, 2 and 98, so on up to what?
Say can be reached till last say till so
49,
no,
51,
no, say
50, 50.
before till say 50 comma 50.
Okay.
So
So what?
then so
So you have 50 classes, right? In this way, you are getting 50 classes.
yes, yes. And 50
So what?
classes are Yes. So therefore, yeah, so if we select 52, then one box would be containing, so we can use PHP here, and it should be 51, I
How
think.
it is not clear, right? What is the choice of boxes? What boxes you are considering?
So if I select, say, numbers whose sum is divisible by, no. Here the sum came out to be 100, and I forgot to see this divisible. I only saw that the sum is 100.
So each class sum is 100, whatever you are considering, that each sum is 100. So by that, what you want to say?
So now there would be many more uh, possibilities, because the sum is
Okay.
divisible. No, my argument is not right.
Okay. So fine. You can correct it, then tell me. Anyone else? Anyone else? These 52 integers are arbitrary. They can be anything. So anyone?
Say if we
Let me give
have
you some.
a 1 to 49 in consecutive integers, just for example, then
Okay.
you can so if it's higher than 49, uh,
Huh?
say any random number, say 100 or 200 or in between, then we can decompose it in parts that consist of the classes.
How you are decomposing it into classes?
So if you multiply 1 to 49 any number with another, say for 49 times 3 or 49 times 15, you get all the
Okay.
rest of the numbers beyond 49.
Okay. But how
Oh
you'll
no.
get rest of the all numbers? This
Oh
is
no,
not
no,
clear to
no,
me.
no, not that right. You don't get the primes.
Yeah.
Sir, do we need to have the numbers in sequence or any numbers would do?
Anything can be works. Why it should be in sequence? You can arrange it in a sequentially increasing or decreasing order, but this can be arbitrary positive integers, right? This can be anything very large or very small, anything.
Sir, can we argue like
Any
this? If you take any number, for example,
okay,
then there's what gives another number that is divisible by 100? So by that logic, say if you take 2, then the number that will uh, give the sum that will be divisible by 100 will be made by something like 98 or 198
right,
or 298.
right,
So for each
right.
of the type of say 1 2 or some integers, you have
Huh?
to exclude another integer, right? If you
Okay.
construct class wise,
So for
then
one integer, you need also another integer. You need some
yeah.
except. That is
So
fine.
if you exclude 2
Okay.
for 98, say if you include in your set 2, then you have to exclude
Huh.
98, 198, and all of the such forms. Then
Right. I
if
can
you
exclude that,
continue
right?
on till 50, then 14, then you basically get less buckets and more numbers. So you have to have for 52
But you
integers.
have also choice of after, like, suppose you consider two up to 1, 2 up to 49, then you start with 101. How well, like, you need how many element? 52 element, right? So these are 49, 40, 102. So this is 51, this is 52 element. So now what you will do? This set I gave you 52 cardinality set, right?
So the set of the set where 101 will lie will also
Hmm.
consist 99, will also consist of 199, and so forth. For example,
How it will consider 199? Because I gave you a 52 positive integer cardinality set. Now can you give me numbers whose sum is divisible by
I'm
100?
I'm talking about classes.
Okay, you are talking about classes.
So
Okay, so
each
what are
class
your
will
classes?
consist, yes. So if you number say S1, in
Ah,
S1 if you
so
give, yeah. No, there will be a lot of other elements beyond one. So it will go. So for example, S1 will go like 1, comma 99, comma 199, comma yes, and so forth. Yeah. S2 will
Mhm. Right.
yes. This is the construction.
Yes.
So if you continue, then you have
Mhm.
more numbers than the classes.
Okay. So yes, you are correct. Your intuition is completely correct. You are correct. So this is the exact idea. So we have this thing S50 up to this S50 consisting of 50 class of 50 that is 50 comma what will you consist 199 298 50 50 100
150.
150 200 so on so all these things. So this will be 50 classes, right? But we have 52 elements, so there should be two elements lying in same class, right?
Yes.
So we are done. But are we correct? I guess let me cross verify because we are breaking this into classes. That is fine. So we have 50 classes, 199.
Excuse me, sir. Uh,
Yes.
in the question, it is written that it is either difference or sum. I may be wrong.
For negative, you can if you are I guess in question your question you are writing it for any 52 integer. I am taking positive integer, so we are done. For negative, it's the same thing you can do.
Distinct integers, non-repetitive.
Yeah, distinct positive integer you should write. Distinct positive integers. So now is it clear? I hope this argument is correct, so I don't need to write anything more. We are breaking this into classes, so we have 50 classes and 52 elements. Pigeonhole principle. One of the classes, all two elements should lie.
Sir, but the question says we can choose any of the two elements. So once we choose one of the elements over here, then we are fixed with a given bucket.
No, you have 52 elements, right? These
Let's
52
say, sir,
elements.
I choose 150, then I'm no, cannot go anywhere else. I know that there is only one place I can find 50 or other combinations.
See, you are not understanding correctly. So let me explain you again. So what is the thing we are saying is you have these classes, 50 classes. You are breaking this set of positive integer into 50 classes, right?
Yes, sir.
So now you have given 52 positive integers and you have 50 classes. So one of the class must should contain two elements, right?
Oh, that's where the problem is, sir. I can understand one of the elements I can take from one set, but you are
Hmm?
making me fix the say that the other element should also come from the same set.
No. Like you have 52 elements.
Yes, sir.
52 elements. Let's say A1, A2 up to A52, right?
Yes, sir.
Let's say A1 is belonging here, A2 is
Yes,
in
sir.
this set, A4, A50 is here somewhere.
So can
Now
you give
where
me an example, sir? I'm not getting without that thing.
this is 52 cardinality is too large. How I will write this thing?
No, sir. Not the entire thing. Any two numbers whose sum is divisible by 100. That's what I'm asking. From
Yes,
the any of the two sets.
in each class sum is divisible by 100. In that
Yes,
way
sir.
writing class only.
Yes,
Yes,
sir.
in that way only. Yes.
I think
What
Yeah, we have to. I
there has
got.
been a mistake in constructing the
Yes,
classes
yes,
because
yes,
if
yes. There is a mistake. I got your idea.
yeah
Uh,
actually the buckets don't actually add up to divisible by
100.
100.
Like yes, you are correct. This thing. Suppose take this thing. 99 and 199.
Yes.
Yeah. So this is not correct. But idea is perfectly fine. This should work somewhere. Okay, let's erase this and write again. Okay. Okay. Let's suppose your given set of 52 integer is S is A1, A2 up to A52 of 52 positive integers, right? Huh. We need to write here difference also now. I realize. This is positive integer, positive integer. There is two element whose sum or difference. We should write or. Now it is fine.
Yeah, now it's
Now it is fine. Your construction is perfectly correct. So this was my fault. Right? So we have the
because
same
for
classes.
some it didn't go right. Is it
Yes,
possible, ever possible for some? What kind of
I
bound
don't
can you
know.
have for some?
I never tried. So you can also try. Then we can discuss in next session. But just try it. But for this question, the answer we already did. Class of 2, 98, 198, all these things. So on, so on, so on. Up to class of 50. 50, 50, 50, 100, 150. So this thing. So this is clear. So by pigeonhole principle, among 52 elements, 2 elements should lie in same class. That implies their sum or difference is divisible by 100. So we are done. Anything, any more doubt? Now you can ask, or otherwise we are done. But the interesting question, whatever name, I can't see the screen, the name of the person, but he raised an interesting question. So I already write the question that what is like given set of 52 distinct positive integer, then there exists 2 elements whose sum is divisible by 100. So can you do for sum, what is the least choice of number of integer, like when we can say that their sum is divisible by 100? So this is an interesting question. You can try and can answer in next session. I can also try if I have time. So this is the answer for this question. Anyone have any doubt, you can ask. Otherwise, we can move ahead. We have 30-40 more minutes remaining, so we can now do some interesting problems. So this thing is clear to everyone, right? If not, just respond quickly. I can see the participants. How many participants are there? Okay. Anyone? Any doubt? Fine. Okay. Let's go ahead. Huh. So this is another interesting question. Let a comma b is a natural number and the natural number b co-prime positive integers. Co-prime positive integer show that there exists x comma y belongs to natural number such that ax minus by is equals to 1. Right. Can anyone give me some idea or can some approach to do this problem? A and B are two natural numbers which are co-prime, means their GCD is 1. Then we have to show that there exists x and y in natural numbers so that ax minus by is 1. Any idea? Otherwise, I will do, but it is interesting to discuss with you guys and we do the problem by discussion. Otherwise, I can just write the solution. I don't have any problem. Anyone can unmute yourself and answer. Anyone? No
No,
one.
sir.
No one want to ask. Okay. So no idea. Okay, let me give you some more hint, then you will answer. So we have a and b in natural numbers, so that there exists x and y in natural numbers such that ax is congruent to. Okay. So what is this means? What is this means? We wanted to show. Let's write solution with green, blue, blue. Wanted to show ax is congruent to 1 mod b. If this will happen, that means what? That means that ax is congruent to 1 mod b. That means ax is equals to 1 plus by for some y in natural number union 0. That means ax minus by is equals to 1. Then you will get this thing, right? This is the same thing.
Yes.
So now you need to show this. Ax is congruent to 1 mod b. So what is the idea? Can you give me something? Think about Euclid lemma kind of thing and try to construct, use somewhere pigeonhole and this kind of idea. Can you think something? Let me give you something more. Consider this thing, this sequence or set, whatever you want to say. This A and B are given to you, right? So A and A dot 2, A dot 3, so on so on, A dot B minus 1. And the interesting thing is B does not divide S for any S belongs to S. Can anyone give me some argument for this? Why? Just clearly, quickly. What is the argument for this? Why B does not divide any element of S?
B does not divide A, and B certainly does not divide any number smaller than it.
So by that what? Like
So
scale.
they are basically products of one. A is not
4,
divisible.
4 does not divide. So what? Like you are saying 4 does not divide 2, 4 does not divide 2, but 4
No,
divide
no.
2
So
dot 2.
you but
So what you want to say? Can you say again? What you want to say?
A and B are co-primes, right? So you have
Yes.
A, but A and B
Yes.
are not co-primes here, right? You have written 4
Here,
and you have
here they are
written 2.
not correct. Here they are not correct prime. So what you are using? So prime number, this property always holds. P divides AB, then P divides A, and P divides B. But here they are not. So how you are using this? Can you justify me? Here B need not be prime. It is just co-prime to it. So how you are using this? Can you explain?
Since we are going in like A into 1, A into 2, A into 3, therefore therefore all the 1, 2, 3 are obviously less than B, and we will only be able to divide it only
2
if
is less than 4. 2 is less than 4, but 4 is dividing 2 dot 2. This is the simple.
uh,
I gave you a, this. 2 is less than 4, but 4 is dividing 2 dot 2. This is the simple. 2 is less than 4, but 4 is dividing 2 dot 2. I gave you this. 2 is less than 4, but 4 is dividing 2 dot 2. This is the simple. 2 is less than 4, but 4 is dividing 2 dot 2. Tell me, this is some basic theorem, class 10 theorem. So I guess you know this. But do you know Euclid's lemma? What is that? Yes, this is the Euclid's lemma. Just I use this here. So that means B does not divide S for any S because GCD of B comma A is 1 and uh, and B cannot divide anything lesser than B. So that means this B does not divide any element of this set S just by using Euclid lemma. So now this is clear. So can you think something now? I have give you some more or less enough hint how you should proceed. You need to show that ax minus by is 1 for some choices of xy you should show. So I gave you some set and show something. Now can you give me something more than this? Any idea now? What do you need? You need after dividing by b, remainder should be 1, right? This is the possible choices of what? Like 1, 2, up to b minus 1. Possible choices of x I gave you, right? Now you are saying that I need remainder 1. I already told you remainder cannot be 0 because these numbers are not divisible by b, so remainder cannot be 0. Now, for this statement, I need at least one number for which remainder is 1. So how you will proceed? Can you give something more to me? Anyone? Are you getting the idea or not? You have given a and b, so and you need to construct x and y such that ax minus by is 1. So that's what we need. Ax is congruent to 1 mod b for some choices of x, right? We need to construct the choice of x. So I construct a set which is basically a dot 2, a dot 3 up to a dot b minus 1. This I am 1, 2 up to b minus 1. This I am taking as a choice of x. So now does not divide s for any s belongs to s. So that means the remainder cannot be 0. And we need the remainder 1. We need the remainder 1. The remainder will be 1. Then we have for some number, let's say a dot k, the remainder is 1. Then we have ak is congruent to 1 mod b. So we're done. We got the required thing. So you have to show there is a number for which remainder is 1. So how you will proceed? Are you getting this or not? Otherwise, I can explain again.
Sir, please
Anyone?
explain it again, sir.
Okay. Okay. Huh. So you have given A and B to natural numbers, right? And they are co-prime. So we want to show that ax minus by is 1 for some choice. We want to show that there exists x and y in natural numbers so that ax minus by is 1. So that means we wanted to show that ax is congruent to 1 mod b. This is the same thing. But we need to construct the choice of x and y. So I am constructing a set which is basically a dot 2, a dot 3 up to a dot b minus 1. Now this is this clear to you or not that b does not divide s for any s belongs to s? This is clear, right? This is clear.
Yes, sir.
This is just a Euclid lemma. So that means if b does not divide s, then remainder cannot be 0. Then what are the possible choices for remainder? 1, 2, 3 up to b minus 1, right?
Yes, yes, sir.
Yes. Now if I got for one number remainder 1, then I am done. Because then ax is congruent to 1 mod b. We are done, right? Is this clear or not? Hello.
So the last
Can you?
part is again a bit confusing. So you are saying that we have got b minus 1 buckets.
Okay. Okay. Oh, till now I didn't go to bucket. Bucket I will tell you, but let me write. Okay. So we have possible choices for remainder. Choice for remainder, remainder after dividing elements in set S. So what are the possible choices? This can be 0, this can be 1, this can be up to b minus 1. But this choice of 0 we already discarded, right? This cannot
Yes.
be possible.
Yes, sir.
Now I am saying that I need one number such that the remainder is 1.
Yes, yes.
I need one. Yes. So suppose this does not hold. Suppose this does not hold. Suppose there does not exist any number, any element in S such that remainder is 1. Right. So we have how many choice for remainders? So we have the choice. So the choices for remainder. रिमाइंडर के लिए क्या क्या चॉइसेस बची है?
2 से लेके b minus 1 तक.
Yes, 2 to b minus 1. So how many these are b minus 2 choices, right?
Yes.
Their cardinality will be b minus 2, but we have how many numbers? These are b minus 1 numbers. In S we have b minus 1 elements, right?
Yes.
So at least by pigeonhole principle, since S has b minus 1 cardinality, that means 2 elements in S should have same remainder, right?
Yes.
Is this clear?
Okay, sir.
So that means 2 elements should have same remainder. So let's say these element will be of the form x1 and x2. How they will look like? X1 is of the form a dot b minus a plus r1 r, and this is a dot b minus k2 plus r2. They will be of this form, right? Clear?
Yes, sir.
Simply I can write in this way more clearly. This can be write in b a dot k1 or a dot k2, where 1 is less than k1 is less than b minus 1, 1 is less than k2 is less than b minus 1. Yes. So this means, can you see something now? So x1 minus x2, this is same thing r, right? Both have same remainders. So what is the x1 minus x2?
A times k1 minus k2.
A times k1 minus k2, right? Right. You can choose k1 less than k1 is greater than k2. If that's not the case, you can do other thing, right? X2 minus, so that this number becomes positive. I just want to make the calculation as positive. So now what is the thing? X1 minus x2. Okay. Okay. So now this k. Okay. Okay. Hmm. So what this line means? Let me explain. So what does this mean? This means that x1 is congruent to, more precisely, a dot k1 is congruent to a dot k2 mod b. Right? This is the thing, same thing, because this r minus r is 0. This is the same thing, right? So because the remainder is 0, because this thing is what? A dot k1 minus k2. This is congruent to 0 mod b. So that means B divides, since B does not divide, say B and A are co-prime, that means B divides K1 minus K2. This is contradiction. This is by Euclid lemma, which is contradiction since K1 minus K2 is lesser than B. So B is strictly lesser than B. So which is contradiction. So that means this implies there exists a number, an element S belongs to S such that such that such that S is congruent to 1 mod B. That means S is of the form A dot K is congruent to 1 mod B. This will implies A dot K is congruent to 1 plus By. This implies AK minus Y is equals to 1. We are done, right? Any doubt? Any doubt? Anyone any doubt? Please respond, otherwise I will not get whether you are. Is it clear or not?
Clear.
Yes, sir.
Okay, fine. So let's do some more problems. We have some more time. This is interesting. Let's do this. Let phi be any arbitrary age coloring of K17. K17 by colors red, blue, and green. Prove that there exists a monochromatic triangle in K17 under the coloring phi. Anyone any idea? First understand the question, but this is saying that phi be any arbitrary age coloring of K17. K17 means a complete two uniform graph on 17 vertices. By colors, by red, blue, and green, we have given 3 colors and we need to color the graph of K17. This is given to us. Prove that there exists a monochromatic triangle. So that means there exists a triangle with same color in K17 under the coloring phi. So is coloring phi के अंदर K17 में same color का triangle मिलेगा. So this we need to show. Can you tell? Anyone any idea? This type of question should be done in your class. Something is should be, there may be some example in your class you have done this kind of stuff. Any idea? No one want to respond?
Don't know how to proceed.
Okay. Abhishek, do you have any idea?
Sir, I think we need to consider the possible K3s in K17.
How?
Uh, S- I'm still thinking about it.
Okay, you think. Let me give you some hint. Then you will think. Okay, so we have given 17 things, 17 vertices, right? So let's say these are 17 vertices. Huh. So now we need to, okay, color them by, we now, okay, so this is 1, this is 2, this is 3, so on, this is 17. So by pigeonhole principle, we wanted to color them by, wanted to color 17 ages, sorry, कितने ages होंगे? 16 ages, right? 16 ages. 16 ages from 1 to 17, 1 to 1 to where? 1 to 2, 3, up to 17 by 3 colors. So by pigeonhole principle, there will be at least 6 vertices, and there will be at least 6 edges. 6 edges of same color. Let's say red. Right? Is this clear? Is this clear? There will be 6 vertices of red color, at least red, blue, or green. Something I'm saying red. Is this clear?
Yes, sir. Uh,
Yes.
but are you only considering 16 edges? Because that's there.
Yes, yes. I am only considering these edges, connecting 1 to 2, 1 to 3, 1 to this, 1 to this. These edges I am only considering.
Oh,
These 16 edges I am considering. Only first, initially I am considering only this stage. Is this clear? There will be 6 edges at least of color.
yes, yes.
Yes. So, so let's say these are of red color. So let's draw them by red. So we have this one, and to here we have 6 edges of same color. 5, 1, 2, 3. Let's say name them by A1, A1, uh, A1, A2, A3, A4, A5, A6, A6. So we have 6 red edges. These are connected by 6 red edges. 1 red edge, 2, 3, 4, 5, and 6. Now these 6 are connected by red edges, right? So if they are A1, A2, or A2, A3, or A1, A3, or anything is connected by red edges, then we are already done. Then we have a monochromatic thing, right? Monochromatic triangle. Correct or not?
Yes, yes.
So they cannot be connected by red color. So let me write. Now these 6 vertices A1, A2, A6 cannot be connected by edges of red color. So they can be connected only by blue or green.
Oh, this gives a contradiction, right?
What contradiction? Can you see?
Yes, the among the five vertices, the K5 will definitely will have at least one red edge
Why?
because we have three colors and there
Okay.
K5 so in K5 you have 15 edges. So if you color them all, you cannot have all of them with the green and blue.
No, you are not correct. Why? Why? Because you have six vertices, and I am saying that they can be connected only by two colors, blue and green. So what is the contradiction? You can do that, right? What is the contradiction? You have six vertices and two colors. They cannot be connected by red color, right? If they will connected by red color, you will get a monochromatic triangle already. Now I am saying that they are not connected by red colors. This thing is clear, right? Please respond. Is this clear?
Yes.
So if they are not this ये हिल गया पूरा ठीक है let me erase this okay so now okay AI and AJ cannot be connected by red color. Okay, I should not write in this way. If AI and AJ is connected by red color, then we are done. Connected by red color, then we got required monochromatic triangle. If AI and AJ is so if AI and AJ is not connected by red color, AI and AJ is not connected by red color. If AI and AJ is not connected by red color, they will be connected by blue or green. So what we have, so we have six vertices and two colorings, blue and green, right? So now we have this case, six vertices and two colorings, namely blue and green. So we have six vertices, A1, A1, A2, A3, A4, uh, A4, A5, A6, right? Now start coloring. So we have six vertices, we want to color them with two colors. So can you help me now? Now you can use again pigeonhole principle. Now at least there will be three edges of same color, right? By pigeonhole principle. By pigeonhole principle, there will be three edges of same color. So right. So let's say they are of blue color. Say of blue color. So let's connect them by blue color. let's say these three are of blue color and remaining two are of green color. This is of green color. So now again, let's do. Now this A2 and A3 cannot be connected by blue color. So it should be connected by green color, otherwise we are done. So if this is connected by blue color, we are done. So this should be connected by green color, right? Now this A3 and A4 cannot be connected by blue color. If it is connected by blue color, we are done. If it not, then it will be connected by green color. Now A2 and A3 is connected by green color. A3 and A4 is connected by green color. Now if A2 and A4 is connected by green color, then we will get a monochromatic triangle. If this is connected by green color, we are done. If this is connected by blue color, then we are also done, since we have this A1, A2, A4 monochromatic triangle. So we are done in all cases, right? So we got a monochromatic triangle if either of AI and AZ is connected by for 2 less than I comma j less than sorry 2 less than I comma j less than 6 if either of AI and AZ is connected by mm, by 2 less than this is 4 connected by blue green. What color? Blue color. Blue. Now, so we got a monochromatic triangle if either of AI and AZ is connected by blue. So if not, sorry, why I'm changing this? If not by blue, it should get connected. It should it should all get connected by green color. Mm, which color? Green color. In this case, we also get required monochromatic triangle. So we are done. So yes, any doubt? Any doubt
No, sir.
in this one? Is it clear?
Sir,
Yeah.
so in the first step, we say that we are connecting
Hmm?
one with the remaining 6
Uh,
with
remaining 70
remaining
with three
70
colors.
with 3 colors.
Remaining 16, sorry, remaining 16 with three colors. Okay.
Mm-hmm.
So by pigeonhole, at least one will be get connected by 6 colors. We have 6 rays of same color basically.
Okay.
So let's suppose these are of red color.
Yes, sir.
Then each AI and AJ I from 1 to 6 cannot be connected by red color. If they are connected by red color, we are already done. We get monochromatic, right?
Okay.
So if they are not connected by red color, so they will be connected by blue or green. So now we have 6 vertices and they are connected by blue or green color. So we have make another cases. So I then by pigeonhole, at least we have 3 edges of same color. So let's they are say they are of blue color, right?
Hmm.
So then we again do the same calculation. So then since three are of blue color, so they cannot be connected by uh, blue color. So they will be connected by green. So if this is connected by green, this is connected by green, then if this if this is connected by blue, then we already get monochromatic. If this is connected by green, then we again get monochromatic. So we are done.
Yes.
Yes. Is this clear to everyone? Abhishek, is this clear?
Yes, sir.
Okay. So with this, let's stop here today. So we will do something more in next week. If you have any more doubt, you can ask, but I will stop here. If you want to ask anything, you can ask. Otherwise, you can leave.
Sir, I wanted to ask regarding the assignments. So
Yes.
how formal do we need to be?
Since I'm not an official NPTEL course TA, I'm a PMRF working as a TA for this NPTEL course. So I'm not much familiar with these things like how much precise you need to do, or but I guess they are contributing to your grading, so you should be precise, right?